So in our last lecture for this Intro to R module, I want to give you some tips on good coding practices. And this will help you remember what you did when you come back to a script maybe a month later and you're trying to decipher your work, and it'll also help someone that you share your script with to reproduce your work and to be able to figure out what you really did. So the first thing you need to remember is that it's good to start every R script with a description of what it does. So let's try and make this little messy selection of code that we were practicing on here a little bit more user-friendly. So the first thing I would do, and it's often you've got code that you're testing and it's maybe not going to be what your final code looks like, and you just want to remind yourself that this is kind of your messy section. So you can do anything that'll help you remember that whatever comes after this, or you can call it whatever you want, that is not actually your final script. So what you would want to do is then start your script with a brief description of the purpose of the script. So here we are practicing data imports in R. So it can be anything. So the second thing you want to do is you want to load all your packages that you're going to be using in your R script at the beginning of your script. You might not know initially all the packages that you're going to be using, but as you go along, you'd want to put that all at the top. So maybe we want to use the ggplot2 library. Then you would add that to the top. Any other libraries at a later stage. We're going to be using the vegan library and so on. So one thing that's important to remember is to improve the reproducibility and the usability of your code, you want to limit hard coding in your script. And what I mean by that is you want to keep all the source files for a project in one directory and use relative paths to access them. And that's exactly what we did by creating a project, so we didn't have to specify the absolute path where to find our input file. And then you want to define all user-specific code, so that would be maybe a directory path that another user that tries to use your script might want to change at the beginning of the script, so straight off they know what sections of code they might need to change and they don't have to go and pick through your code. So if we look at these two examples, at the top here we've defined where to find the input file exactly, what the output file is, and then after that we read the input by referring to this variable that we've created named input file. As opposed to just reading in the path as is here and then having to repeat that again down here and again down here. So if you were a secondary user, if you'd structured your code like this, it's much easier to just go change these two lines at the top and know that the rest of the script is fine to use. Instead of how I previously specified the input file, just calling it by name, I would rather go define a variable right at the top of the script to reference that file, and then here I will just replace this with infile. Another thing that's really useful for longer script is to break your code into logical sections and to use comments to inform your script. So remember that you can use the Control or Command on Apple Shift R. Command Shift R, and now we're creating a specific code section. So maybe here we're actually doing our data imports. We say OK, and that creates a nice tidy section for us. And now we maybe read in our code here, And when you see the arrow there, it means it's collapsible. So maybe I'll have another code section later on, and that might be data analysis. And now it's easy for me to walk through my script by just collapsing these sections. Another thing that you'll find that becomes very useful as you start getting more comfortable in R and you start coding a lot is that you'll have repeated code sections that are very similar, and you'll find yourself kind of copying and pasting and modifying them. In the end, you'll have a really long script with code blocks that are actually redundant. And those you actually want to build into functions. It makes your script more legible and less error prone. And these functions you'll typically want to define also right at the start of your script. And then recording session info. That is something that is useful to share with collaborators so they know exactly what packages you used, what version specifically. So if we just do session info, it'll tell me exactly what packages I have at the moment. So for instance, if I do library vegan and I redo session info, you can see it's now loaded vegan 2.55. And then it's always really useful to get someone else to review your code, especially if you've been staring at this one script for days or weeks and you really can't see your own errors anymore, or someone else uses your script in a slightly different way and they pick up bugs that you weren't aware of. That's very helpful. And then use version control. Either start by just naming your scripts with version information if you make major changes, or what you'll find useful, and I'll show you an example, is something called GitHub Gists, which is just a little snippet of code. So in this case, I have a collection of microbiome custom functions, and we'll be using some of these in a later module. And I've shared this code, and you'll see first I call all the libraries that I'll be using. Then I have a whole long commented section of the functions that are available in this script. And then I have the actual functions. And so what makes this GitHub Gist especially useful is that you can track revision information. So if I make a change here, users of the script can go and they can see exactly what I've changed and why I've changed it. So if we click on the revisions, GitHub will show you exactly what I changed. For instance, here I removed the library Pfeiffer line because that was no longer needed. I inserted some other code, resized the PDF a little bit. So that's a really nice way to store little scripts that you might want to share with other people. And then finally, there's a nice link here to Good Enough Practices in Scientific Computing. And it's a paper that really just discusses good practices on various fronts. So data management, software, collaboration, project organization, and so on. And it's something that's useful to read through before you plan a project. The final resource that I'd like to share with you guys is called the TinyVerse R Style Guide. And as the name implies, it's a comprehensive style guide for coding in R, and it's something I wish I was aware of when I first started coding in R. I encourage you to work through this resource. Let's look at an example. So they'll give you little snippets of code, and they'll give you an example of what good code would look like and what bad code would look like. In this case, they're highlighting the fact that here you've got a long line of code and it's not as easy to immediately pick up what the different arguments are than it is in this one where you separate each argument on a different line. Now, also go through functions. How should you name your functions? How should you structure them? File naming, documentation of your work, error messages. So it's really very comprehensive, and also committing your code to GitHub. So that's really it for our introduction to R module. Thanks for listening, and I hope you found it useful. And just as a reminder, you can find all the links to the syllabus material as well as the useful links on this h3o_bionet_r page.